All right. Hello. What's up, team? Y'all ready to learn? Okay, so here's a quick, or yeah, we'll see how long this is, but YouTube recap of limits and derivatives coming on to our intro to calc quiz. So I'm just gonna go through a couple problems, and a lot of info will be in the email as well. But let's go over limits. So limits, right? There's 3 steps for limits. I can actually come up. First step is to just plug it in and you'll get an answer. Okay, so the first step is awesome. You plug it in, and if you get an answer, you're done. Okay, now the second step, right? This one has a condition. The condition is if I get 0 over 0, then I need to factor or FOIL and simplify. And then I can, after that, repeat step 1. Okay. And these will typically be perfect squares. So, I mean, you guys should notice right away, like, oh, I'm probably going to have to FOIL this, or I'm going to have to factor this. Step 3, all right, this one has a lot of criteria. If I get a number over 0, square root of 0, okay, so limits, this is not 0. You need to do left and right. Absolute 0 over 0, 0 over absolute 0, or certain piecewise ones. Then I need to do left and right hand limits. So then left / right limits. Well, you can pause this. You should know this. It should be ingrained in your hearts, right? So let's do a quick. Oh, also, I'm a little congested, so I'm sorry if I am sniffling. But let's take this limit. The limit as x approaches 3 for the function 1 over x squared minus 9. Okay, so first step, right? Just plug it in. 1 over 3 squared is 9 minus 9. We get 1 over 0. Okay, so knowing our trusty steps, which are in your brains, this falls in the third category. So third category means that we need to do a left and right hand limit. So 3 left hands. X approaches 3 from the right hand. Okay. The left hand, this means, okay, let me draw a little diagram. This means that if I'm approaching x equals 3, okay, this is just a regular number line. Left hand means I am looking at the value of 3 that is just to the left of it. So this left side, okay, this little minus sign, this doesn't mean necessarily negative. It just means I'm on the left side of 3. So if I plug in a number that is just a little bit smaller than 3 into our original equation, right? Let's say that this 3 I plug in is just a little bit smaller, and I square that guy. What would I get? I would get 9, but something that's just a little smaller than 9. Okay, and I can denote that with this little minus if that helps. So I'm taking 9, that's just a little bit smaller than 9, and I'm subtracting a whole 9. Okay, this would bring us all the way over to a 0. Okay, but a 0 what? Right? It's a 0 on the left side. Because if we're taking 9, that's a little bit small, and then we subtract a whole 9, we will end up at 0, but on the left side of 0, like this, on this left side, right? So if I plug this in on the left hand, I would end up with a negative 0. Now, looking at this problem now, I have a 1 divided by 0, but it's not necessarily 0. This is a number that's really close to 0. So this 0, right? Any number divided by a really small number is going to give us infinity. Okay, because that cheese can go on forever. Okay, and then one thing to note is that what's in front of it? We have a negative. Okay, because we're on the left side of it. So you would get a negative infinity limit for the left-hand limit. Okay. Now, if we do the right hand, that would be on this side, the right side of 3, right? Plugging it in. It's the same train of thought. If I have a 3, but just a little bit bigger, and I square that guy, I would get a 9 that's just a little bit bigger than a regular 9. And then if I subtract a whole 9, you would end up at 0, but on what side? Right? You would end up on this plus side, just on the right side. So this would mean that I get, actually, let me just rewrite this. Okay. Right here, I would get an infinity, because again, it's not 0, it's a number really close to it, but it would be a positive infinity in this case. Okay. So when we have left and right hand limits, which is step 3, you have to do both the left side and the right. And then your final answer, we would put final limit. Okay. This has to have our left hand equal to our right hand. Okay. But in this case, what did we get? Negative infinity and positive infinity. So in this case, that would not be good. So our final limit, because the left and right hand don't exist or don't equal each other, would be does not exist. Okay. And I would expect all this work, or not all this stuff on the right, that's for explanation. But this left hand, right hand stuff, I would need to see that. Okay, so let me zoom out. There you go. Let's try one more of these. So the limit as x approaches 4 of the function x minus 4 divided by x squared minus 16. Okay. And right off the bat, as I see this, like your brain should itch a little bit, like, oh, I'm probably going to have to factor or do something with that perfect square on the bottom. But because we want to be super diligent, we're going to plug in our x equals 4. And you would get 4 minus 4 on top, 16 minus 16 on the bottom, giving you a 0 over 0. Okay. So what step was this, right? We got to ask ourselves. We got step 2. If you get 0 over 0, factor, FOIL, simplify. So I would take my perfect square on the bottom, split that guy up like this, okay? And then look what happens. Our x minus 4s simplify out, giving us an x, 1 over x plus 4, okay? Now the next step is to repeat step 1. So step 1 is, as the limit of x approaches 4 of 1 over x plus 4, because this time we're reduced, you would get 1 over 8. And that is a totally acceptable answer. Cool. Here it is. Awesome. Okay, so I'm probably going to have around maybe 4, something like this. But let's go on over to slide over to the last part of our limits, which are infinity limits. So these are really easy, right? Infinity limits mean that our x is either approaching infinity or negative infinity. Okay, and this one's also going to have 3 rules. First rule, okay, if power is biggest on top, okay, our answer is going to be either positive infinity or negative infinity, right? If, and then I don't really want to write that again. If power is biggest on bottom, this means your answer is 0. That's it. That one's great. We love that one. Step 3, if power is the same, okay, you would take the coefficients. So take coefficients. Oh, that's, yes, coefficients. Yeah. Okay. So what do I mean when I say power, right? Let me just whip up some problems from my brain. So let's say I had the limit as x approaches infinity of, let's do them in order. So power biggest on the top. Okay. Oops. Something like this. Okay, this looks horrible, but infinity limits are super simple and exciting because we only need to look at the biggest powers. Okay, so in the numerator, that would be the x cubed. That power is the biggest. And in the denominator, that would be x squared. Okay, so going with our checklist on top right here, if the power is biggest on the top, which it is in this case, you are going to be either positive or negative infinity for your limit answer. The way to do this is take both your powers, both your biggest powers, the top and bottom, like this, and then you're going to reduce these powers as much as you can. So you would get what? 4/2, just x, right? Cool. And then your last step is to just take your limit as we approach infinity and plug it in, right? If I plugged in infinity here, right, it doesn't necessarily matter what I have in front. This is just always going to become positive infinity, right? So if this was a negative, right, then it would be negative. Let's try step 2. If the power is biggest on the bottom, so we had limit as x approaches negative infinity of 3x squared over 6x 5. Okay. Don't stress too much. This one is smaller. The one on top is smaller than the x to the 5 on the bottom. So your answer is just 0. That's it. Lastly, let's assume that we actually had two that were the same powers. So we had x squared plus 4x to the 4 and 7x to the 4 minus 8. Okay. Look at these. Boom. These are the same. We just want to take the coefficients. So the 4 in front of the x to the 4 on top, and then the 7 in front of the x to the 4 on the bottom. And that's it. Boom. And obviously, if you can reduce, that'd be cool. So here are infinity limits. Okay.